Welcome back, everyone. Today we're going to be doing a Kuta software worksheet on radical equations. So let's go ahead and get started. So radical equation is any equation, something with an equal sign, that has a radical in it. So just kind of give you the basics of it. We apply the power rule to all of these problems. So the power rule means we can raise both sides to the same power, and it'll still keep it equal. The one thing we have to do is we have to check for extraneous roots. So make sure you always check your answer at the end to see if it makes sense. If it doesn't make sense, then there's no solutions. Or some solutions might be extraneous and some might not be, so it's important to check every one. So here we square both sides and we get x. That's how we undo the square root, and then we get 100. So then we plug it in when we're done. We get 100, square root of 100. Does that equal 10? Yes, it does. So we have an answer for number 1. Let's skip down to, let's do number 8. So we can square, let me stick with red. So we can square both sides again. Okay, sorry, that's a 2. When we square it, it undoes the square root, and now we just have a simple one-step equation. We subtract 9 to both sides, we get n equals -8. So we need to plug this back into the original problem. We get -8 plus 9. Is that equal to 1? We have square root of 1. Does that equal 1? Question mark. And the answer is yes. So here we have our solution. N equals 8 is our answer. X equals 100 up there is our answer. Okay. Let's do number 12 as another practice. So with number 12, actually, let's just skip to 13. So for 13, this is the same thing. Now, here's the problem. You don't want to square both sides right away, because if you square this, you have a binomial, and you're going to have to FOIL, and it's going to be very messy. So the first thing you want to do is you want to get the radical by itself. So step 1, you want to isolate radical. Okay, so we subtract 10 to both sides. We get square root of 10m minus 1 equals 3. Now we're ready to rock and roll. So we square both sides, 10m minus 1, it undoes the radical, equals 9. Now it's just a two-step equation. We add 1, we get 10m equals 10, divide by 10, divide by 10, we get m equals 1. If I'm going too fast, feel free to pause, rewind. Okay, these are all things that you guys can implement to make it easier for you, but I just want to make sure I get through enough problems. So we have m equals 1. I need to plug this back in. Don't circle that answer yet. So we have 10 plus square root of 10 times 1 is 10 minus 1. Is that equal to 13? Question mark. So I have 10 plus the square root of 9 is 3. Is that equal to 13? Yes, it is. So m equals 1 is our answer. Okay, let's do one that looks a little bit more complicated. Let's do number 18. So with 18, we're going to square both sides. The radicals are already by themselves on both sides of the radicals. So we can, it's not like we need to combine radicals on one side. We can go ahead and square. So once we square the radicals, we undo both at the same time. So we get n over 6. Since there's a fraction here, what I would recommend is multiplying everything by 6 to get rid of your fraction. So once you multiply by 6, you get 12n. I need to do 88 times 6 real quick. Don't have a calculator with me, but it's okay. 48 plus 4 is 52. So I get minus 528 equals n. I'm going to subtract both sides by n. I get 11n equals 528. Still don't have a calculator with me, so I divide by 11. That goes in 4 times. That's 44. That's 8. I get 88. That's 48. So I divide both sides by 11. I get n equals, what did I say? I get 48. Now I need to check that answer. So I have 48 times 2 square root minus 88. Is that equal to square root of 48 divided by 6? Let me start on the right side. Right side looks a little bit easier. So I have square root of 48 divided by 6. That's the square root of 8. I'm going to leave it like that because I hopefully will get square root of 8 on the left side also. So once I get the 2 times 48, 2 times 48, we get, I'm having a brain fart here, 96 minus 88. So that's the square root of 8. Is the square root of 8 equal to the square root of 8? Question mark. Yes, it is. So we have our answer. Our answer is n equals 48. So that's a more complicated one. Maybe we should do one more complicated one for the road. Let's scroll down to number 23. 23 has a fraction. We already did one like that. We'll go ahead and do 25. So with 25, we're going to square both sides. Square both sides. 2k plus 40. Because the radicals were by themselves, we can go ahead and do that. And now it's like a multi-step equation with x on both sides. We're going to add 2k to both sides. Add 2k. We get 4k plus 40 equals negative 16. I'm going to subtract 40 from both sides. So once I do that, I get 4k, subtract 40, equals negative 56. What goes into 56? 4 times, is it 13? 13 times 2? No. Is it 14? I believe it's 14, but it's going to be a negative 14. So we get k equals a negative 14. We have to check this answer. So we get 2 times negative 14 plus 40. Take the square root of that. Is that equal to negative 16 minus 2 times a negative 14? Let's do the right side first. It looks a little easier. We have negative 16 plus 28. Okay, left side, negative 28 plus 40. That's going to be positive 12 on the left, square root. Is that equal to positive 12 square root on the right? Yes, it is. Guess what? K equals negative 14 is our solution for number 25. As you can see, it's not too bad. The squaring is like really the only development that's new from normal equations, and then checking to see if the answer makes sense is the last part you normally wouldn't do. Hope this is helpful, and I'll see you next time on Wes Explains Best.